All right. So in this lesson, we are going to discuss about data structures, which is 1.4.2 of your syllabus. And the learning objectives that I have here for today is that we are going to understand about the following data structures. Like we are going to discuss arrays, records, tuple, list, queues, stacks, graphs, linked list tree, binary tree, or hash table. And along with these data structures, we are going to discuss how can we move data from one data structure to another? How can we add them? How can we remove the data from these structures? So, a short starter questions right here from you is that what do you mean by the term data type? Do you have any idea? Or why do we use data type?
Okay, so a data type is a type of data that is just given like a specific name, as in like you are like given what type of data it is. For example, you are given a character or you are given a string, an integer, a float, boolean.
Hmm. What you are trying to tell me is the name of the data types. But if you are going to look deeper into it, you will understand that if we have different types of data containers, by data containers, I mean those containers which are used to hold some type of data may have different types. Like, for example, if you're going to contain a student's age, so it's going to be a number. If you are going to store a student's name, it is going to be a string. So data type specializes in these areas, and what you really know about a data type is the primitive data types. That means they include integer, boolean, char, float, and string. These data types are basically built into and defined by the language. By building into means you are not going to program if either a data type is a number, a true or false, a sentence or a number. They are built in, means they are already created. They might contain a single value, and the amount of memory each takes up varies from language to language and from processor to processor. That means different data types can hold up to different languages and they can vary. But what is the meaning of the primitive data type? So a simple definition is right here that states that primitive data types are the basic data types that are provided by a programming language as a building block. Why as a building block? Because with the help of these data types, you are able to program and you are able to identify different programming capabilities. Most language allows more complicated composite types to be recursively constructed from the basic type. Like for example, you can have a char, an integer, float, or boolean, or as an extension, a string data type can be constructed behind the scene of many char data. What I'm trying to say is that in the primitive data types, in front, you can have a data type such as a char, but at the back of that or behind the scene, or maybe if you wish to extend a programming language, you can also add another data type, but these are known as the primitive data types. So when we talk about data types, we have two types. One is primitive and one is non-primitive. Do you know about non-primitive?
Okay, so primitive data types are data types that are usually defined by the language and they only contain one of each value.
And non-primitive,
They contain multiple values.
they contain multiple values. I think non-primitive data are known as reference types. Like these are the complex data structures that do not store the actual values directly, but what they store is a memory address, or if you want to refer to a different location. This is non-primitives. So if I ask you about primitive and non-primitives, can you summarize this in one line, like about primitive and non-primitive data type?
Okay, so primitive data types are data types that are usually provided in language are just usually known as building blocks
Okay.
and allow for more complicated composite types to recursively function.
Hmm. And non-primitive?
And non-primitive types are data types that are usually more simpler.
No, no, you are going to say that non-primitive data types are more complex data structures that are created by the programmers. They are used to hold collection of values, or they are used to hold complex entities, or they can store memory storage data. This is non-primitives. But primitives is like basic building block. Can you say it again regarding the primitive and non-primitive data types?
Okay, so primitive data types are data types that allow for more complicated composite types to be in recursive construction, and non-primitive data types allow for even more complicated types that usually start from complex types.
Can you give me some example of non-primitives?
Um,
See, I sent you a message on WhatsApp regarding primitive and non-primitives.
Arrays, objects, and strings.
Yes, yes. Do you get it now? This is
Yeah.
non-primitives. And primitives are integer, string, char, real, boolean, like this.
Hmm.
Now, what do you know about the abstract data types?
Is it how we like view the data?
Abstract data type is, yeah, you are right. Like how do you view the data, or how it is organized into the container, or how it's being holded. So the operations can be carried out that is created by the programmer rather than defining itself within the language. Like for example, a queue of print jobs. If you give 5 printing jobs from your computer to the printer, you are going to understand that the new job is going to come from the rear, and they are going to be completed from the front. This is a queue. When we talk about the stacks, you can look at the example of a stack of books, that if you want to remove a book, you're not going to remove it from the first one, as it has more books on top of each other. The easiest and the quickest way to remove a book is that you remove it from the top. Another example is a list of tasks. If you want to add more tasks, they can be added to the end. But if you want to complete them, they are removed from the front. Or maybe a tree diagram or a graph. We are concerned only with what the data is representing, but not the how it is being implemented. Are you getting it?
Yeah.
But now, if I talk about the data structures is a collection of data that is organized to allow efficient processing that represents the data held in a computer memory. If you have a collection of data, you want to organize that, you want to allow efficient processing, you are going to use the data structures. They represent the data that is held in a computer memory. So different data structures can lend themselves to different applications. And some data structures are highly specialized to specific tasks. Like for example, an abstract syntax tree is a data structure that is used in compilers for representing a structured code. Like, look at this uh, graph right here. Like, the first data structure is an example of an array. So, An array, you can see that this is an example of a data structure. And why this is an example? Because this is one of the ways of storing elements in a contiguous memory. If you might remember the concepts of IGs, on that level, I explained you very quickly regarding the concept of the arrays, that if you want to store the elements into a contiguous way, contiguous means sequentially, you are storing them one by one. Then we have tuple. Tuple is an example of a data structure, but it is of fixed size. It is ordered collection stored in a memory. Then we can have list as well, but when I'm talking about list, this is a bit ambiguous, as it is treated as still an abstract data type, because a tuple is the one that describes the behavior of sequence of operations rather than it is being implemented. If I talk about the linked list, so linked list is a specific pointer based implementation. A specific pointer based implementation, like for example, you have one box, or you can think of a linked list as a chain. I mean, a normal chain, as you can see that the chains are linked with each other. Then we have stacks, queues, trees, graph, and I'm going to get into them one by one to help you explain them. Now, I want to ask you, like, why the data structures are built upon the primitive data types? Why not non-primitives?
Is it because primitive data types represent memory easily?
Mm, I think they are not built on primitive data types because of recursion. Like non-primitive data types are themselves the data structures. I mean, arrays, linked list, all of them are the non-primitive. And primitive is char, string, real, boolean. So data structures are built upon the primitive data types so that you can use them. But when the non-primitive data types, it's about the containers. Are you getting my point?
Yeah.
Similarly, if we have a data structure, this is a way of representing the data held in a computer memory. Or complex data structures are often made from simpler one another. Now, before I start the lesson, there is some key terms that you should be considering. Like the first key term is static. Static means like size is set at the beginning of the program and it does not change at the runtime. Runtime means when the program is running. For example, I said that you can only take 100 US dollars from me for 1 month. That's it. That means this is an example of a static. Static means there's the limit, the size. It's set at the beginning and it will not change over the month, right? This is static. When it comes into programming or data structures, you can give them static limitations or you can give them static sizes as well. Like this is going to be static. This is going to remain as it is and it's not going to change. This has one advantage that it is easy to program and the space required is known. But if I talk about the dynamic size, you can say that I'm giving you 100 US dollars in this month. And if you require more, you can come back to me in a week or more, or we can change the amount as per your expenses. This is dynamic because it's changing every time. It's changing upon your requirement. So it has less limiting. That means you can expand it, you can shrink it. It's more complex to program and it can use a lot of memory because every time you are changing it. And potentially you could run out of memory as well because it's requiring recursively changes. Are you getting it?
Yeah.
So can you tell me about this static and dynamic?
So static data structures are only set at the beginning of the program. They're usually like limited in size and they're like easy to program. Whereas dynamic can change at runtime because there's barely any limits and causing it to be more complex to program as it uses lots of memory, meaning they can run out of memory.
Perfect. Another important key term that we are going to discuss right here is about the immutable and mutable structures of data. Immutable data structures cannot be changed at runtime. By runtime, I means when the program is running. Mutable data structures can be changed at runtime. I mean, for example, if you are testing a program and in the middle of the program, you feel like you wish to change the value, so it's immutable. So you can set the value as you desire. Oh, sorry.
Alright.
I mean, immutable is you cannot change them, right? You cannot change them. But mutable is it can be changed. So if you wish to change a value during the program or during the runtime when the program is running, you can say them mutable. But if you cannot change them, it's immutable. Complex higher order data structure can be made from the simpler ones. For example, out of a stack, you can create an array, stack using an array, or binary tree from a linked list. We are going to discuss these data structures one by one. Another important key terms is insertion or add. I means if you want to add it or if you want to delete a data item from a data structure, you want to delete them, you want to remove them, or if you are looking for the surging. Choices of data structure determined by the data to be stored can have impact on the runtime efficiency. If you remember, we have discussed this runtime efficiency with the big O notations. I mean, which big O notations is it, right? Like which
Yeah.
level? So we can also measure the efficiency of them through this way. Then we have the concept of memory management. Like memory of data structures is taken from a memory heap. Do you know what's a memory heap?
What is it?
A memory heap is a large, flexible region of a computer memory that is reserved for the memory allocation. So temporary memory can be used for local functions. Like a heap works like it has dynamic sizing of memory. By dynamic sizing of memory, I mean to say it can expand or it can shrink dynamically as the program runs. It do not have a fixed order. Data can be stored, accessed, and deleted in any sequence. It has a good level of accessibility, means anyone can access that. And you can also refer it to as a pointer type. Pointer means it can refer to other locations or other data types. This is an amount of memory that is allocated to a programmer at your when the program is running. Spaces can be automatically allocated or deallocated as required because it has sizing. Do you get it?
Yeah.
Now I'm going to start it with the concept of an arrays, right? So can you explain me what is an array?
So an array is like a set of items that are usually grouped using a single identifier, and they are usually addressed by the variable name in a subscript.
It's a set of a data item of the same type, grouped together using a single identifier, and each of the data items is represented by a variable name as a substring. Like for example, let's say name of students. What is the identifier here? The identifier is the name of the student itself, right? And what are the values in that? Maybe Zed, Ali, Hashim, or anyone else. So you can see that in an array, the data type is supposed to be same, and you are going to have one identifier that's the name you are going to call it, and each of the data item is going to be addressed by a variable name or a subscript, right?
Yeah.
Let's say, for example, number of students and name of students. So this is two lists, right? This is two arrays. Are you getting it?
Yeah.
Like if I talk about the structure of the array, the structure of the array is like index number, and elements. So one, two, three, four, five, six, seven.
Mm.
And here you can have your any number of elements. Like this is an example of an array. But what you need to take care of that, in an array you have an index number, you have an element. So you can see that DFG is at which location? 4.
4,
DD is at which location? 7.
7.
So you have elements and their locations.
Shouldn't it
Similar.
start from 0?
Yeah, it's up to you. You can start from 1 to 7, or you can make it like this. It's same. It's up to you. Like for example, 0, 1, 3. The name of this is student's name. This is Ali, Fahad, Hashim. So this is an example of an array. This is your index number. This is your elements, and the name of the array is a student's name, right? Similarly, you can also say that this is an array of the number of students. So you have 80 students in class 0, 15, 1, 13, 2, 3A has 5 students, 4 has 44. But one thing you need to take into consideration is that arrays have arrays have same data type. They have one name, right? You get it?
Yeah.
Arrays is one of the simplest data structures. It's static. It cannot change in size at runtime. Runtime means when the program is running. It has a collection of elements, each within an index. It can hold data of a single data type only. The data items are stored in contiguously in the memory. It has zero index normally. It's a quick and easy and direct access to data with a single command, like elements are running. It has an index register that is used to determine where a specific index is in relation to a base address. It means that numbering, as I was telling you, and it's mutable. That means that the data can change. Do you have any confusion in any of these lines?
No.
Now look at here. I just gave you this example regarding the data structure that